Now in complex analytic function, we'll be looking at residue and we'll be solving few problems on it. Before that, please like, share and subscribe this particular channel and click on bell icon to get a new notification. Let us start now. Now coming to residue. First we'll be looking at the theorem, then uses, then the formula. Okay. Come to residue theorem. It is a complex analysis. It is a powerful tool to evaluate the line integration of an analytic function or a closed curve. Okay. It can often be used to compute real integration and infinite series also. Okay. This is nothing but residue theorem. Basically used to find the line integration over a closed curve very easily. Okay. Now, in general, residue of z at z minus a is denoted by residue of a or residue of z as z tends to a. Okay. What is a? E is nothing but a singularity point. Okay. Or you can consider this as a pole. Now, if you consider integration, then how to solve this one is nothing but integration over closed curve f of z dz is equal to nothing but 2 pi into residue of a or residue of a is equal to 1 by 2 pi into integration of a closed curve f of z dz. Now, general note point you have to remember is nothing but it generalizes the Cauchy integration theorem and Cauchy integration formula also. Okay, it means residue would be by residue by deforming a Cauchy integration theorem and Cauchy integration formula also. Now coming to formula or calculation residue. If z is equal to a is a pole of order n of f of z, okay, then residue of a is equal to 1 by n minus 1 factorial. Limit z tends to a will be differentiating n minus 1 times with respect to z of z minus a whole power n f of z. Okay, this is a basic important formula you have to remember. Now, if you consider n is equal to 1, then it comes in a simple pole, right? Z is equal to a is in a simple pole. Then residue of a is equal to limit z tend to a z minus a f of z. Okay, no need of doing any differentiation in this particular case. Now, if you have a special case like f of z is equal to p of z by q of z, such that p of z should not be equal to 0 and q of z should not be equal to 0, and z is equal to a is a simple pole of f of z, then the residue of z as z tends to a is equal to p of z by q of z. Okay, this is the general formula of a residue. A simple question. Consider function f of z is equal to 5z squared plus 3 by z minus 1 whole square. Find the residue of f of z. Okay, now they given the function f of z is equal to 5z squared plus 3 divided by z minus 1 whole square. So first what you do is to find the pole. We can see that z is equal to 1 is a pole of order 2, right? Now we have to find the residue at z is equal to 1. The general formula we know that residue of an f of z as z tends to a. The formula is given as 1 by n minus 1 factorial into limit z tends to a d by dz n minus 1 times differentiation into z minus a whole power n into f of z, right? Now we define the value of n and a. You can see that n is equal to nothing but 2 and a is nothing but 1, right? E is nothing but a pole, n is nothing but order of it. So we'll be substituting it to find the residue. So residue of f of z as z tends to 1 is equal to 1 by 2 minus 1 factorial into limit z tends to 1 d by dz of 2 minus 1 is nothing but 1 only, right? 1 time into z minus 1 whole square into f of z is given as 5z square plus 3 by z minus 1 whole square, right? Now substituting it, we know that 1 factorial is 1, so 1 into limit z tends to 1 d by dz of these two get cancelled, right? It becomes 5 z square plus 3. So which is equal to nothing. Just differentiate it. Limit z tends to 1. It becomes 5 into z square, 2 into z. Now z is equal to 1. So 5 to the 10 is equal to nothing but 10. So answer is nothing but 10. Residue of a function f of z. Now come next question. The question is, consider a function f of z which is equal to 4z squared by 2z minus 1. Find the residue of a function f of z. Right. So they given the function f of z which is equal to 4z squared by 2z minus 1. Right. Now first we're defining the pole. We have one pole at z is equal to 1 by 2. Right. So we define the residue of f of z at z tends to 1 by 2. Right. Which is equal to nothing but, we know the formula, residue of f of z at z tends to a is equal to nothing but 1 by n minus 1 factorial into limit z tends to a d by dz n minus 1 times of z minus a into f of z. Right. So we're writing the same thing here. N is equal to nothing but 1, right? And a is equal to nothing but 1 by 2. So we get 1 by 1 minus 1 factorial into limit z tends to 1 by 2, and it's a simple pole, so no need of differentiation, into it becomes z minus 1 by 2 into f of z as well as 4z square by 2z minus 1. Right. Now to cancel both of them, you have to consider LCM effect, and 0 factor is nothing but 1, so it becomes limit z tends to 1 by 2 into it becomes 2z minus 1 by 2 into 4z square by 2z minus 1. 2z minus 1, 2z minus 1 get cancelled. One side goes 1 and 2 side, which is equal to nothing but it becomes limit z tends to 1 by 2 to z square, which is equal to 2 into 1 by 4, which is equal to 1 by 2, which is equal to 0.5. So residue of a function f of z is equal to nothing but 0.5. Now come next question. Question is, consider function f of z which is equal to 9 divided by z minus 1 into z plus 2 whole square. Which of the following are residue of a function f of z? Right. Now they given the function f of z, right, which is equal to 9 divided by z minus 1 into z plus 2 whole square. Right. Now we have to find residue. When you see the poles, okay, we have two poles, z is equal to 1, isn't it? Simple pole. Right. Now the second one is nothing but z is equal to minus 2, isn't it? Pole of order 2, as we have z plus 2 whole square. So we have to find the residue for both of them. Okay. Now coming into the first one, z is equal to 1. Okay. We find the residue. We know the general formula of a residue of f of z, and z tends to a. Formula is given as 1 by n minus 1 factorial into limit z tends to a d by dz n minus 1 times, right, into z minus a f of z, the general formula to find the residue. Now we consider z is equal to 1, right? So we get residue of f of z as z tends to 1 is equal to, it becomes 1 by 1 minus 1 factorial into limit z tends to e is nothing but 1 d by dz of 1 minus 1, right? The simple pole, so n is 1 into, this becomes z minus 1 into 9 divided by z minus 1 into z plus 2 whole square, right? So just substitute it, we get residue as z tends to 1 f of z is equal to 0 factorial is nothing but 1, so it becomes 1 into limit z tends to 1, right? Now dz of 1 minus 1, it becomes 0, right? So no need of differentiation, and these two get cancelled and becomes 9 divided by z plus 2 whole square, right? So when you substitute 1 here, it get 9 divided by 1 plus 2 whole square, which is equal to 9 by 1 plus 2, 3 square is nothing but 9, and then get cancelled, which is equal to nothing but 1, right? Now in the option 1 is not given, so we'll be going with the z is equal to minus 2. Now residue as z tends to minus 2 f of z is equal to 1 by n value is nothing but, here it is 2, so it becomes 2 minus 1 factorial into limit z tends to minus 2 d by dz, n minus 1, right? N is 2, 2 minus 1, 1, so it will be differentiation 1 into z plus 2 whole square into 9 divided by z minus 1 into z plus 2 whole square, right? These two get cancelled now. Now we get in 1 factorial. 1 divided by 1 factorial is not but 1. 1 into limit z tends to minus 2 d by dz of 9 by z minus 1, right? Which is equal to nothing but, when you differentiate it, okay, then you get, it becomes minus 9 by z minus 1 whole square, right? So just substitute minus 2 here, we get minus 9 divided by minus 2 minus 1 whole square, which is equal to minus 9 by minus 2 minus 1 minus 3 whole square, it becomes 9, which is equal to minus 1. So in the option, the answer is option A, right? We have 2 poles, so we have a 2 residue, and in the answers we got 1 and minus 1, so in the options we have only minus 1. So which of the following residue of a function f of z is nothing but minus 1?